Chassis construction, so there's a lot of information. We've got two very good car builders here that have brought some presentations to show on chassis construction, placement of tubes, materials, welding practices, and things like that. So I'm going to let those guys take over a lot of that and talk about it. So we got Spencer Harp and Brandon Norman.
Yeah.
That's going to come up and talk about those things.
After Dowlin's wreck, I got with Kyle Brown that owns Harris, and this is their 2025 design. I'm not a chassis guy, but from what everybody said, it's a lot better, more up-to-date design. So they just wanted me to show it that they made a lot of improvements after his wreck. So we'll get Spencer up next, and I'll let him kind of tell who he is and what he does, and he can brag on himself.
And if you want to come up here, it's fine too.
I'm going to. I was just trying to make sure my mouse and stuff right.
Okay.
It's going to work from there. Let me see if
It works good.
I think it will. I think the mouse will reach that far. All right, I'm not much of a public speaker, and I appreciate everybody being here. I've never really had to do this with a mic in my hand. My name is Spencer Harp. I own Sharp Manufacturing and Sharp Engineering. This is kind of spawned off of some childhood hobbies and so forth. I swore I was done with dirt track racing when I got 18 and said I was going to college and doing something different and keeping my nails clean. But things changed. I circled back to it. I had a son. And then when he was 3 years old, he was making circles around a pine tree in the yard, so I knew it was genetic at that point. Cash can kind of attest to some of that as a guest in the room here. But I've got a master's degree in applied engineering. I did an undergraduate degree in mechanical engineering at Georgia Southern University, and I had some help with this presentation from Ethan Smith. He's a manufacturing engineer at GSU. He's a former student of mine. Basically, most of you probably don't know me, maybe not even seen my face, but I've got 12 years really directly involved in the industry, and then I can kind of go into sort of what we do from a chassis side of the house. Man, this mouse is a little sensitive. But the two companies I have, Sharp Engineering, we kind of focus on innovative solutions for the industry, and that could be industrial or race car related. And then Sharp Manufacturing is the fabrication side of that, so we kind of divided those two entities a few years ago. And we do a lot of white label chassis production for different builders, across the thing. So, I mean, you may not know we built it, but several of the cars that are all over these tracks today were manufactured in our shop. All of the CNC tubing cutting, the plasma cutters, the JD squared, all that type of stuff that came out. I'm not taking credit for it, but in 2011, we actually had one that was built in my shop, and that sped up production. So we're a fairly small crew, but the amount of volume that we can push out is pretty substantial. So sort of an outline of what I've got. I don't want this to be a college lecture, and I'm trying to refrain from that. But there's a lot of material, there's a lot of information, and I felt compelled to come up here and kind of just speak to what I knew, what I've been shown as best practices. Don't take anything that I'm saying as concrete or you must do. I may be wrong. I mean, I don't profess to be the most intelligent person in the room or in the sport for that matter. But stuff that I've seen, stuff that I've tried to correct, things that I'm, working on. My son's 11 years old now. He too started racing karts when he was 3. So that story that Ben was telling about that guy they were working with kind of resonated. I mean, 3, now he's 11, got a 602, runs one of our cars. We started building the Sharp Mini late model in 2016. It's sort of what really got me back into the sport. That's a scaled down dirt version. I was too poor to race the big stuff, so I was trying to find a cheap way to get back and go fast. But I'm not giving you a sales pitch on that. Y'all can look it up if you want to. But the main outline for this presentation was, what is a space frame chassis? And unfortunately, I got to assume everybody in the room is at the same level of knowledge on it because, while this presentation's for you guys, it's, has a lot to do with the viewers that we have online now and the people that are going to play this thing over and over. I assume that a lot of people don't want to get here because they don't want to admit they don't know what they don't know. And so it's an embarrassment thing or whatever. I don't care. But if one person takes something away from this presentation and applies it, I felt like I've done my due diligence on that. But we'll talk about material selection, welding techniques, load path, structural triangulation, common issues, some safety regulations and some discussion points, and we'll kind of open it up, for a conclusion on that. But space frame chassis, is primarily what we're all racing now in the dirt scene. It's just a triangular network of 3D tubes. So all we're trying to do is brace for impact. And we're one of the only racing, bodies that doesn't have a centralized safety organization that sort of mandates what we need to do and how we need to do it. So, as I go through the presentation, start, kind of look at what we've got. What you see there, clearly that's not a dirt track car, but that's an exaggeration of triangulation, but that is a monster truck chassis. So the number of bars that are going crisscross, it talks about load paths. These things are designed to be jumped 20 feet in the air and, and land on their roof and the driver survive. Key design principles, triangulations, node alignment, stiffness versus weight, and serviceability, or, kind of what's going into these chassis. So node alignment, and I left my, and like I said, I've got some good examples of it, but it's just really, if I had two bars come, well, that one doesn't work, Brian. I thought we fixed that. I'm just messing around. There's a couple of them. I got one back there too. Josh Bishop is in the room, and there's one right there in front of you, man. It's green. You might be colorblind, sorry. And watch mine not work. If it doesn't work, we'll just talk through it. Okay, so just say I've got a upper halo, and I've got my down bar that's coming in and welding in that way. And if I put some sort of a brace in it, if I put it in here, this point, when I say node, that's what I'm referring to, is where those 2 points come together on a bend. I've got some good examples of that. The relationship of where the bar is to the node, so coming up with a halo support bar to this point right here, you're not nodal. Several sanctioning bodies regulate how far that point can be from the node. We don't have anything like that in the dirt industry, but we'll get there. Triangulation, I forgot I put this side in here, guys, sorry. But that's exactly what I'm talking about. So, this picture is from Formula SAE. Now, Formula SAE is a student racing organization across pretty much the entire world, where these students design and build chassis and come together and compete annually. Some people have been involved in it here. I was a faculty advisor of that program at the university. So I had, their rule book for a student organization car is 247 pages long. I would say it's ridiculous, and it was when I was having to deal with the rules, but in hindsight, it's not. And feel free, guys, anybody that wants to chime in, I like to talk, but I don't want this thing to be monotonous either. So chime in, grab a mic, whatever, tell me to shut up. And then you've also have the other side of the SAE world, and that's Baja SAE, where they design chassis for like an off-road version of the same concept. So you've got your guys that want to jump, play in the mud, and you've got your guys that want to go fast around a little road course. This is a simulation that was done by a college team, Baja SAE team, which we all had to do, but it just shows you the sort of a finite element analysis of what the chassis was going to do in impact. So what's simulated here is a frontal impact on the front, what kind of deformation you would get in that scenario, and a side impact from the side to see what kind of side deflection was there. I don't know how many builders in the industry are using FEA to validate their chassis designs, to any kind of capacity, and I'm sure some of the big ones are. But I mean, the dirt scene has been an evolutionary product, from literally cutting laps in somebody's backyard to what it is today. But there are tools and technology out there like ANSYS, and even SolidWorks has some built-in simulations if you're not familiar with it. So if you're designing in SolidWorks, which some of these newer, younger builders may be doing, you can run simulations on that, and you could probably get some organizations to even sponsor a seat of it, because you're doing good for the racing community by doing that. Load paths, when I'm talking about load paths, we're talking about forces that are entering the chassis, going to a location, and then where they're going from that point. So the frontal impact or whatever, in the FEA side of the house, I can tell you what bar is being loaded and how it's being loaded. FEA can predict weak points. So obviously we need to physically inspect chassis, et cetera. If you hear me say in a little bit talking about forces and vectors, what a lot of people don't understand is just because you've got a bar braced one way, you need to think about the degrees of freedom that node has and make sure it's being supported from other directions. I've seen several chassis that have some triangulation in it and they appear to be good, but if they took a hit or rolled a different direction, the entire cage would collapse. You know, so there may be, you know, right side bias for the triangulation or left side bias for the triangulation. But anytime there's an impact, there's a force vector that goes into that. And, you know, the clear illustration of it's a dog. You know, if I pull on a dog's leash, I've got an upward and a backward motion. So that just kind of shows you what I mean about a force vector. Load paths. This is a chassis that we were working on with a guy, you know, trying to optimize, and, you know, and I just took it and drew some squiggly lines on it so you could see. But basically, if I took a impact on the front left of that halo, I'm going to have forces going down the A pillar, and vice versa. So there's forces being transferred anywhere in the chassis. Walk, you get the frame over here? Okay. So the forces are, let me get a little closer to it. When I point to the lines, 10-4. So if I get a hit, usually I have a mouse pointer or something, but if I get a hit in this corner here, I'll have forces coming down this A pillar that are being transferred into the, you know, this brace here. And I did this intentionally. I put this up here so you can see that this point right here, it doesn't have a direct load path into the bar beneath it. And I'll talk about that in a second, but you see this a lot in the dirt industry. Like, you can go across chassis brands. I don't care who you're looking at, what brand you're looking at. Some things I want you to look at when you're buying a car, inspecting a car, talking to a builder, or even considering building one yourself, is think about the load paths. Where the forces are going in this chassis in the event of a rollover, in the event of a hit. You know, what type of scenario you know, would happen. You know, if I landed here, what's keeping this point from collapsing down? Well, in this particular chassis, it's, you know, the bending resistance of this bar, and then the brace here that's supposed to hold up that corner, right? You're talking 2,400 to 3,400 pound vehicle landing on its roof. The forces that go into that are fairly substantial, even in a rollover scenario. So when the force goes here, it's transferred into here, and now the only thing holding that point up is the bending resistance of this section of tube right here. And I'm putting a shadow on it, so I'm sorry. There we go. So in reality, that bar here, this door brace, should be in line with that so that the force can continue to come down the chassis, come down to here, and eventually get down into the brace. So the more direct the load path is, the stronger it will be in that direction. You know, and so you can go around the car and just kind of visualize, think about the types of impact that you're going to experience. You know, I'm not a pessimist by any means, but, you know, think about worst case scenario in the event of a crash. You know, where's the you know, like if I'm laying on my side, I roll over and I'm on the side of the car. What's my points of egress? What's being blocked, you know, by these braces? Can we do something different with the bracing to, you know, make egress easier? And if I'm standing on my side, Cash brought it up last night, what are we doing for underbody bracing and structure?
Yeah,
Are you hitting the bottom of the car?
That was something I was fixing to talk about. You know, one of the things that, as you're looking at car construction, you know, look at injuries of things that you know about. So Kevin Swindell is a perfect example. You know, sprint cars are fairly safe. They're designed to be rolled over and over and over and over. No one ever designed one or thought about getting, you know, hit in the bottom. And that's what hurt Kevin, was he turned over and then got hit in the bottom. And that's what did his damage to his spine and things like that. And it made some changes in the sprint car world from that wreck.
Yeah. And it's extremely difficult to brace for a bottom of car impact. None of us, you know, want to be hit laying on our side in a car. We all get that. We also all understand that racing is a dangerous sport, and there's, you know, you can go to an extreme with this stuff. But like I said, I'm just trying to point out things to think about and look at sort of the best practices to use, you know, when doing it. If there's something you can do that doesn't jeopardize, even if it jeopardizes a little bit of performance, but isn't hindering your, you know, something, and it's just one extra bar. What is that one extra bar? Every car out there at the racetrack right now has lead on it some capacity. You know, we keep making these cars lighter and lighter and lighter, you know, for the sheer purpose of moving that lead around and having, you know, the ability to get more rear weight bias or whatever to put it where we want it. It's what we're telling ourselves. But I think we're doing that at a sacrifice to safety. I got a couple of, you know, just one or two images at high profile failures. This picture that's on the screen here, we were racing Talladega with my son. My son was running a 602 at Dega, and he got down, he's like, Dad, I really want to go to the museum. And I'm like, okay. And it's like, man, we gotta get home, it's cold, you know, Talladega wore us out, we sucked. But, you know, we got better as the night went on. But so I took him to the museum. I never walked through that museum, and I encourage everybody here or anybody that's in the area of Talladega to walk through that museum, because firsthand you can see the evolution of the race car chassis. And I've got 50 or 100 pictures, you know, from, you know, like A-mods to, you know, vintage modifieds, et cetera, that go all the way up. And then I got to this room and I saw this particular chassis. So as I was there, I knew I had this presentation coming up, and I was like, man, I said, this is perfect. Now I can write it off as a business expense, A. And B, I can go through and get some good examples of, you know, sort of the evolution. We don't have all day for me to stand up here and show you pictures and talk about things. But when I got to this, the hair stood up on my arm, right? If you don't know what this is Michael Waltrip's 1990 crash where he hit the opening on the wall. Like, nobody wants to do that. Nobody would have predicted that. We can't even design a car to withstand that type of impact. But he hit that opening, and it shredded this car. And the fact that this, you know, he walked away from it is, you know, an act of God or whatever your beliefs are, or you know, miracle, whatever. But he he walked away from this crash. The seat, and my hair standing up on my arm now, the seat is literally hanging out of the left side of the car. You know, my biggest fear in working in this industry is someone else's life. Like, you know, if I go to a racetrack and I've got 15 cars, like the mini late model class, every car that's out there I manufactured. With the exception of 3. And you see 17 of those rolling a racetrack, and it's just like seeing your kid walk out into a baseball field or, you know, jumping into some high-risk activity. You know, when we first started, I mean, literally the hair would stand up every time, and it wasn't because I was excited they were on the racetrack or whatever. It was sheer fear for me because I knew at that point I had 17 people's lives in my hands. So it was extremely, it took me a while to kind of get used to that. But this right here resonated with me significantly, and it goes into a lot of what I'm going to talk about in terms of like heat-affected zones, what kind of failures, what we're looking at for tubing thicknesses, were the load paths correct. It's a very, like I said, it was a very you know, emotional interaction with this actual car. So I encourage all of you to go, if you're a builder or anything of that nature, go look there. You can see the history. You got a question?
Yeah, I just want to point out that that's actually Mike Harmon's car.
Is it?
And that got hit twice.
Did it?
Right? Yeah, so it hit the butt end of the wall. And as it come across the racetrack, Johnny saw it hit him. And it knocked the front end. And
Slap
the
out.
motor was still running by the time it got to turn 3.
That's insane. And they've got a video showing the incident and the wreck, and I mean, it's all on YouTube. You can check it out. But I stood there and I watched that thing play through about 4 times, just trying to see like what the impact was, how it was hit, and then looking at sort of the back end of it, that lap that he's talking about. He said, yeah, it was hit twice. Yeah, the wall ripped it, you know, it ripped it up, and then it laid there, and then it drove through, you know, on the second hit. So I know, that's insane. It's insane. All right, I'm not trying to get too scientific on everybody here. I don't really want to, but I'm going to quickly go through material selection, and I'll probably give this presentation to Brian and make it publicly available. So if anybody wants to go through, I wanted to print out some copies, but the color printer was giving me a hard fit, and it didn't look that good in black and white. Anybody wants to go through here and look at some of this stuff in greater detail, we'll make it available for download somewhere. I'll put it on one of my websites or something. But real quick, the common materials for roll cage construction in here, you know, you've got ERW, DOM, 4130, 4140, you know, different types of material, different production techniques, et cetera. But I mean, get some engagement from the room. Ben, I mean, you can chime in. We don't know who's got the mic at this point, but 4130 and 4140, anybody in here know what the difference between those two materials are?
Was it carbon content's one of them?
Yep.
That's the biggest one I know about.
Well, I mean, why is carbon content in tubing important in an important decision in what we're doing and why we're building it? Any ideas? Carbon content, it controls basically like heat treatability primarily. So a lot of your materials and steels, the higher the carbon content, the easier it is to heat treat. Why it's important in roll cage construction, and it's an important consideration, is because every time you weld something, you're putting heat into it. So you've got a heat affected zone. So if I go back and look at some of these pictures, you'll see a heat affected zone outside the weld, roughly 1 inch. It's where you're seeing a color shift or any kind of discoloration. Well, what happens there, even though you're welding it and it's cooling, you're essentially air quenching the material. And so when you quench something, it becomes harder. So you think about somebody who manufactures knives, a blacksmith. They heat something up cherry red, and you see them dip it on oil on forged or whatever. They dip it on oil. What they're doing is they're quenching it. They're controlling the cooling rate. And what that's doing is controlling the crystalline structure within inside the material that determines the hardness and how brittle it becomes. So what happens when we weld these things, especially when we weld 4130 and 4140 with a MIG welder, is we have very high heat input into the weld pool, and then which effectively gets that tubing very hot, and then we air quench it, which cools it fairly quick, and then we change the grain structure of the material. We're physically altering how the material performs from a material standpoint right at the corner of the weld. So if we go back and look at that Waldrop wreck, or we go back and look at any wreck, or we go back and look at all the race cars that you guys are having to inspect every week, and we're checking them for cracks, where are they cracking? They're cracking right at the edge of the weld. Every one of them, I don't care. I haven't seen a tube yet that's cracked dead in the center. It doesn't happen. And the reason why that's the case is because you're changing the grain structure of the material, creating a stress concentration. So technically, if you look at aerospace use of 4130 and 4140, when they were building fuselages and stuff for airplanes out of this thing, they were either brazing it together at a lower temperature, or they were running it through a heat treatment process, which was stress relieving that chassis, making that joint much safer and much stronger. I don't know, and I may be wrong, I don't know of too many chassis manufacturers that are using chromoly that are heat treating their chassis. Can any of them? Anybody tried it?
Maybe in the sprint car world at one time, but it's pretty slim.
Like I said, I don't know. I mean, I truly don't know.
Sprint car world still today uses chrome moly a ton, but they are 100% TIG welded, not MIG welded, which is what
a
you
much
have to
better
do.
way to do it, because you can control the heat input with TIG welding. So chassis builders building chassis using 4130 tubing, MIG welding it with an E70 wire, whatever wire they had stuck in their welder, you're really shooting yourself in the foot when it comes to strength, longevity, and fatigue life of that chassis.
Yeah, so like late 80s, early 90s, when chrome moly was really big, like in dirt late models, like Bullet, for instance, they used it for years. It was all MIG welded, and most of those cars were a 1 year and done car, or you had to spend a couple hours every week welding everything back together. I mean, that's just how they were.
All because of the carbon content. So I circled that to highlight that. I've got some specs on here, like, pro cons on, why we use ERW, when we use DOM, what's better, that sort of thing. And you've got Docol and other materials out there being, brought into the industry. I don't know if Docol's gotten any better, and somebody in the room may be able to speak to it, but I know in the early stages of its introduction, it was very inconsistent in its carbon content and seam quality, and we were running into issues with the seams splitting in high stress situations. Now, Docol R8, from the market standpoint, is supposed to provide chromoly-like material properties and strength and stiffness with the ductility of your DOM or ERW.
From what I've seen, Docol was basically a fad. It went just about as fast as it came because of those inconsistencies in the cars.
Like I said, I really don't know, and I can't really speak to it. And some people are saying that certain manufacturers are still using it heavily, and that's why their product's inconsistent. I don't know. But the two main things you're going to see, in pretty much all your entry-level divisions, or, well, what should be entry-level divisions now, are ERW and DOM primarily. You're not seeing a whole lot of chromoly being rolled into the street stock and the factory stock scene, for the sheer cost of the material. And if it is being rolled in, they probably don't know why they're using it. It's just being brought in there because it's chromoly. It's better. My preference in all of this stuff is, and this is me personally, people may have other opinions, but I tend to use more DOM of a, thicker than normal wall thickness, just because we've done calculations on what it is. And we're not trying to sacrifice safety for weight gain, not when you have to add 2,000 pounds of lead. So DOM stands for drawn over mandrel. Basically, it's made in a very similar process as your ERW, so it still has a seam in it, but it's drawn through a mandrel, and what's happening when they draw it through that mandrel is it's compacting the grain structure. So when it compacts the grain structure, when it goes through that mandrel, it makes the material stiffer, it makes it stronger, and it makes it a lot more consistent. ERW is basically undrawn over mandrel DOM most of the time because the carbon contents are very similar. You know, DOM has a little bit more carbon in it, but it's got a seam, and that seam can fail. It's used heavily in the racing scene. I still use it in some of our cars, but we tend to put the ERW in non-critical areas where we're trying to introduce flex. You know, that could be a whole nother conversation, but we want to introduce areas for the car to fail. So in the event of an impact, we have essentially a crumple zone, somewhere to absorb the energy. But for the main primary structure, anybody who's building a roll cage for, let's say, I don't know, a 2,000 pound or heavier car, I would highly suggest using DOM for the core and really looking hard at your load paths. We spent way more time on that slide than I had intended to, sorry. And this is something that I've seen more frequently than I would like to admit. You got guys running out to Lowe's grabbing sticks of black iron pipe, going and grabbing a bottle jack bender from Harbor Freight. And I'm not picking on anybody. I mean, it is what it is. But for the price of a cage now, you know, a pre-bent cage for whatever it is you're racing, that seems like it should be a thing of the past, but it's still happening. Black iron pipe, Schedule 40 pipe, quick rundown. It's designed to transfer fluid, right? It's very inconsistent in carbon content. The weld seam was not designed to take any kind of a structural load. It's basically made out of, most of it's made out of recycled scrap metal. So there is no control in that material. Using it in a race car is absolutely ludicrous. So I'll leave it at that. If you want to read more about black iron pipe and why we don't need to use it in a race car, like I said, you can check out my slide later. I got a lot of information on it. Welding techniques, we talked about heat affected zone. I brought this picture in here just so you could see if you didn't know what a heat affected zone was, or you're somebody at home on social media or whatever. Heat affected zone is, you see the area of discoloration and where the color ended. That's the area that got affected by the heat. There's certain things in metallurgy where you're talking about critical temperatures and that sort of thing. You know, if you want to explore that any deeper in the grain structures, feel free to jump on, you know, YouTube or wherever and dig into that. Filling materials, making sure you're matching your filling material to whatever material you're welding is another key important. Don't just grab the welder and assume that it's got the appropriate filling material in it for the application. Running out to Lowe's and grabbing some flux core wire and going home and calling yourself a race car fabricator, you probably should hire somebody to come in and weld it for you. Clearly there's somebody that can weld with inert gas or something like that can produce a better quality weld for the application. And I think there's a couple of other presenters in here that have some really good pictures of kind of what not to do. We'll get to that. And one or two of them, the additional presenters are talking about sport compacts specifically, so I won't spend a ton of time here. I'll just point out a couple of things that I don't like about sport compacts. And one of them, and I'll have to walk down here and I need a stick or something to point at the wall. So sport compacts, this is an EG hatch, 92 to 95, and it's a very predominant platform in the front wheel drive scene. They K-swap these things and they actually do pretty well due to their wheelbase. But from the factory, this is the factory headrest. Well, right now, that's where you technically want the driver's head. So when you're mounting the seat in these things, you're wanting to get the seat as far back as you can to the B-pillar. But when you do that, you lose reach to the steering wheel, you lose reach to the pedals, and relocating the pedals in one of those cars is not the easiest task if you're trying to use OEM pedals. So a lot of times we'll like make a false set of pedals and connect them to the additional pedals, to bring the driver back, whatever the case may be. But I've built a few of these and then said I never want to build another one, just because I don't like the inherent distance here. So you've got a substantial amount of distance between this point and where your roll hoop would be, which makes this angle here very shallow. That shallow angle is often supported from a bar here. I've got a picture coming up that will show you that won't work. In an ideal scenario, you could support from here down to the bottom of the car, which is what these little green lines are for. But when you do that, you really limit your egress window there, which makes it a very difficult platform to build a safe cage in. And he's got a mic, so he can chime in and add to it.
I just wanted to jump into yours because you put a lot more time into your presentation than I did. But he's exactly right. A lot of guys want this bar way up against the window. And if you're actually sitting inside of the car, it is nicer because you almost don't see that roll cage there. The guys that I've dealt with in the past that I run into this situation, that's exactly what they're looking for. I want that bar as far up in the corner and hidden as possible. The problem is, just like he'd mentioned, you're putting so much angle into this bar and it's so long. In a sense, the shorter that bar is, the stronger it is. If you span that out 40 inches or however, 30 inches, whatever that is, you have to move that back further to help support that corner. If you don't, you go halfway. We've got pictures of what halfway gets you. So you're going to have something in your way, whether it's what you want or not. Whether it's hiding it all the way up in the A-pillar, bringing it further forward and less angle, or additionally, your corner support.
Thank you. So here's an example of a collapse on a cage that doesn't have the diagonal bracing that we were just looking at. So you roll the car over, you land it there, you get the Boeing in the center of the cage. There's no support. You know, the roof's now on the driver's head. Hopefully he was okay. We were talking earlier about, you know, random ways to get impacted. So this car had barrel rolled down some straightaway, and you had another car came in and clobbered it straight in the top of the head. So this gets me into something I didn't really get a chance to talk about, but it's the head height clearance. So if you're building a car, especially in the S-Sport compact world, make sure your seat position and your roll cage placement, all that, you've got head clearance. Especially if you're not, which I mean, I don't know who wouldn't run a full containment seat at this point, but if you've got a anti-intrusion bar on the left side, make sure that you've got all the room you need to keep your head from impacting that, because that impact to that bar to the side is where 90% of your concussions are coming from. I have no idea where this came from, but I was just looking at roll cages. This guy's literally hanging halfway out of the car as it's barrel rolling. I don't know if he's okay. I don't know this guy. I don't know anything about this picture. I just saw it, and it was another one of those emotional triggers for me. Like, okay, what happened? Why did this happen? Who didn't inspect this car before it went on the racetrack? Like, what are we doing? That is his glove. I didn't see that until just now, but that is 100% the man's glove sticking out back. And like, come on. That's at least he had them on. Another thing that we see in the sport compact scene is very poor integration to the core structure. We built race cars on metric Monte Carlos, Camaro nose clips. We're doing, subframe connectors. We were doing all kind of stuff with these big cars back in the day because they were weighed a ton. You get in the sport compact scene and the newer model stuff, you're dealing with unibody cars. So any car that I had ever built that was a sport compact, I went through and basically gutted the lower rocker panel and then inserted a 2x3 tube there and then built my cage off of that tube. So there was a 2x3 piece of square stock that went from the back of the car pretty much all the way to the front to try to give me something stronger to tie into. You're dealing with foreign sheet metal that's paper thin, and this guy here, he was following the industry recommendation of a load distribution patch on the bottom of the floor pan, but we can all see what happened to that roll cage when it punched through the bottom of the car over in, my mouse isn't working well here, but over in that area. So that's not what we're looking for. So gusseted connections, tying into subframe connectors and welding into rocker panels are key. You see a lot of this stuff here. This is really, these are just some examples of ways to tie in if you're not doing a full subframe connector or a rocker, inlay. Boxing out an entire corner where you're attaching to the unibody in multiple angles, multiple locations. Even tying into, the A-pillars over here if you're trying to use the A-pillar. I don't know why I put that picture on there. Me personally, I'm not a huge fan of that because you're putting a whole lot of heat into the center of that bar. Like, I don't care if that A-pillar bends when I roll over, right? But you see a lot of stuff like that trying to tie in better in location. So, if you did have, poor tie-ins at the bottom, all of those gusseted, punched hole tie-ins. I mean, I guess that's, you're at least getting a bite on the car a little better. Common issues in chromoly welds, we talked about this, improper heat controls, stress relief, fatigue, micro cracks, and there's some just examples. Sorry, I keep clicking back and forth. This mouse is going nuts. And we've got a seat expert in here, so I'll, feel free to chime in. I see a lot of improperly mounted seats and seat belts, especially in the sport compact scene and the factory stock sort of division. Seat belt redirection around structural members is a problem. Seat belt redirection around your shoulders is a problem. These rules are copied straight out of that collegiate competition rule book that I was telling you about. So in the rules, it gives us an inclination angle from horizontal on how far down to drop the seat belts, how high they could be, and then sort of our belt position for our lap belt, and then the belt position for the anti-submarine belt. It's important that you follow that and you work with the belt manufacturer's recommendations on how to best secure the belts to your car. Putting belts attaching belts to a roll cage in single shear. If you don't know what single shear is where I've got one tab on one side and I bolt up flat on the other side. I've got one shear plane on that bolt. That's less than ideal, but it's pretty much a dirt track standard. We'll weld a tab on, we'll bolt the seat belt to it, and we go racing. Putting that as a second tab there, which costs you another $1.25, doubles the shear stress, the shear area on that bolt. That could, because if you do that, now we're truly trying to shear that bolt. But if you got a single shear tab, you're not only trying to shear that bolt, it's also got a bending moment on that bolt. So it's trying to bend, it'll break the bolt and shear the bolt with single shear tabs. And so some of your belt manufacturers, they sell double shear tabs that can be welded to them. Cheap investment. Follow the user's recommendation, the belt manufacturer recommendation in terms of bolt size, and look for sharp edges in the seat openings, just to make sure that your belts aren't chafing or anything. If you start seeing chafing on a belt, get with the manufacturer, get it replaced. Again, that's cheap safety stuff. It's bolt-in stuff. Anybody, belt manufacturers, you want to add anything to, or seat manufacturers want to add anything to the belt area? I may be 100% wrong, but.
I was with on our part. I think your general guidelines are in line. I know what that comes from. It comes from the competition for the.
Yeah, FSA. That was just straight out of SAE.
For the collegiate stuff. Okay.
That's straight out of SAE. Has nothing. There's no other sanctioning body on that. And I'm sure like NASA and SCCA and all those have different sets of regulations on where they're going. But redirecting of belts was the main thing I was trying to get. I see guys that'll, basically run your shoulder belts all the way down to the floor and put them on there with a fender washer and run them up and redirect them over the seat, and that's unacceptable. I'm picking on a product here. I don't know who made it. I really don't care. I don't like it. I'm just going to state my opinion on that. That Moroso seat bracket that's got a single bolt, the single pole coming into the back of it to a tab. Oh, and the picture up here, whatever shop this was that put this seat bracket on. I don't like it. And the reason I don't like it is if you get any kind of major hard impact, forward or backwards, and that comes loose, where is it going? You're getting stabbed in the back with something. And so, why that we're selling those, I don't know. I can see somebody doing it like in the top picture in the backyard, not knowing any better. But for a manufacturer to be offering that as a solution to seat mounting seems a little bit out of line.
So some of that, even looking at your rear clip structure of the car. So the first year they had the Award of Outlaw finals at Charlotte, I was there with Don O'Neill, and he had a pretty bad flip and landed on the tail section straight up and down. And the way the car was constructed, there was a bar that came behind the seat, and then the rear frame rail went back to the back, and there was no angle bracing where those two intersected. So it shoved basically the rear clip through the seat and pinned him against the steering wheel. They had to cut the steering shaft off the car to get him out from that wreck.
That's a very good point that I didn't mention in the beginning, is like if you're building front clips, and you're building back clips, think about the failure, the way it's going to fail, and where those bars are going to go. I really don't like using chromoly in front ends in particular because, you know, we're a lot more prone to front end collisions. Because if the bar is cracking and comes loose at the joint, or we have a crack we can't see because it's underneath powder coat, we all powder coat our chassis black because they're easy to repair, but you can't see cracks. So if we powder coat them all white, you'd see them. But when it breaks loose, where is it going to go? And that's another one of my like nightmares, is like getting stabbed with a bar through a race car. So yeah.
Yeah, I see where they, you know, a lot of 4-link brackets today are bolt-on, and nobody plates the front side of the bracket on the left rear in particular. You know, that's one to me that should be a mandated plated area to keep, you know, you break a 4-link rod from shoving through your back.
And I don't think the late model scene even has a minimum wall thickness on the back firewall.
No, there's not.
Right. So
It's all
Just seeing
it's
all
all 40
40,000.
aluminum. Yeah.
yeah, I mean, like my son's car is 40,000.
Yeah.
You know, I mean, like I see that.
But that's one thing, you know, looking at cars that I've worked on personally, that's one area that I will pay attention to. And it's like, you know, we're gonna plate these 4-link bars here because you get that in
Write
your
that
back.
down, Josh. 'Cause it's something we need to do. The seat mount at the bottom of the Kirky, I'm not picking on Kirky there. That's actually, I was giving them a high five on that because that allows you to attach the seat to the, you know, to a structure underneath it and gives you some adjustment in it. It's an aluminum bracket, but, you know, I was always told, and this may be wrong, but the seat just kind of positions you in the car. The belts hold you in. But at the same time, I don't want the seat moving around. I don't want the any structure stabbing me or whatever. This is just a question. Fire suppression, I've seen a lot of racetracks across the country. We're getting away from chassis for a minute. A lot of racetracks across the country that, you know, utilize local fire departments and so forth to kind of help support their fire efforts at the track. Now, while that's great, they may not have the mobility in their operation to be able to respond quickly. They may be blocked in an infield. They may be positioned in a wrong spot. My question is, like, is there a way for racetracks, promoters, sanctioning bodies, et cetera, to look at purchasing something like a 100-pound or 125-pound fire extinguisher from Granger for like $2,000, strapping it on an ATV so that they can be a first responder to an incident? You're talking $2,000 investment that could save somebody's life, and they could use it all year. It doesn't go bad. I mean, as long as it reads green, it's good, right? You know, and then the other question was, like, you know, some tracks used to do it, but nobody's enforcing it. Why don't we require every race trailer in the pit to have a 10 or 15-pound fire extinguisher in it? Like, why is that not, when you're rolling a gate, why are insurance companies who insure these racetracks not pushing for that? Yeah, it feels like they could give them a discount on their premium if they made that a mandate. So if nobody's thought about that, maybe something to think about. With my son racing, a lot of things go through my head, you know, as a parent, and fire is my third fear. There's no really order to these fears, but by the way, but they're all pretty much equal. But fire is a huge one. And so as a dad, I thought about, okay, well, I'll just start building side-by-sides, and because they've got some cold suppression systems that are, you know, fairly small. It's called Cold Fire. I don't know if Cold Fire is doing it with somebody else, but they sell these rigs, these drop-in rigs that go in side-by-sides that they have a cold agent that puts out gasoline fires. I was like, well, I'll just build one of those, and that'll be my pit vehicle, you know, so I can run around and respond if I need to respond. And I was actually trying to get some manufacturers, you know, like shops in the area that sell side-by-sides and ATVs to endorse that. So they could donate a side-by-side, if they were local to that racetrack, donate a side-by-side to the effort. The racetrack and some sponsor buy this drop-in rig, put it on the back of it, and now they just sticker this thing up, and now they've got rolling advertisement at their #1 fan base. You know, their biggest users are going to buy it. You guess what I'm saying?
Yeah, I know the other one that a lot of people don't think about is when you go test. You know, you rent a racetrack and they don't, you know, they're not mandating that you have the fire department there or anything like that. I mean, yeah, the likelihood of something happens pretty slim, but what if it does? You know, so as simple as having people on either end of the racetrack with a fire extinguisher, even that you bring, is a good thing to have. I know we personally always had one on a 4-wheeler when we tested. We didn't always keep it on there, you know, at a racetrack while we were racing, but while we were testing, we always had one on. But that's something that is easily overlooked.
Well, and then a wise guy once told me, you know, like a lot of these sanctioning bodies, we're all going to fire suppression systems, and I think that's great, fantastic. But I think we should still have a fire extinguisher in the cockpit, small one. Why?
How many had your fire system tested at the racetrack?
They haven't checked in probably a year and a half now.
Yeah.
Right.
Now,
Hey,
Rick,
Well, it's only a problem.
I
This
mean,
stuff
I
is
don't
only
even
a
know-
problem
Cook used
when it's a
to
problem.
actually require the bottle inside the cockpit,
Yeah.
which was awesome. But then that just went away after, just like every other rule.
Right. It's only a problem when it's a problem. When the media's talking about it, and then it becomes an issue. I get it. I get it 100%. But what I'm saying is, like, a wise man once said, the fire extinguisher in the cockpit is not for you. It's for your buddy. So when that dude's on fire, you pull over, you unstrap, you get out, you do what you got to do, or hand it out to a corner worker, throw it out the cockpit so they can help address the situation. I think that is something that is a $30 deal. Like, why is it not a mandate? And I got my opinions on why people don't mandate things, but not for this conversation. So my reflection on this entire thing was, why are we using materials prone to stress cracking in a safety region of the chassis? Why are we using subpar welding techniques on those materials? And when do we acknowledge the fact that the industry as a whole seems to be prioritizing performance over safety, right? And this is just an open-ended thing here. I mean, at this point, I want to open it up for questions for anybody. If there's got anything for me specifically, we can wrap up or have conversation afterwards. But I tried to cover everything I could. I've been cramming on this presentation for a couple of days.
So as a chassis builder, or other chassis builders, that may be in the room, as far as, being in the seat industry and seat mounting, where if you look at NASCAR, so we're next door to NASCAR and, we have a good relationship with them and we're allowed to go over there and do all kinds of stuff. And they've mandated, so every chassis is exactly the same, right? Seat mounts are in the same place, the brackets are, everything, all the chassis are the same. Now, I know you're not going to get that across, the dirt market or whatever. And I know sanctioning bodies aren't going to do anything because I've had long conversations with those guys and, it just comes down to liability, right? They don't want to tell you to do something and then you get hurt and then they get sued. So, but as a chassis builder, and maybe there needs to be I don't know if y'all meet or y'all discuss things or y'all do this, or there's an association or something like that. But if we could get, certain things, homologated through the chassis process as far as seat mounts go, like NASCAR does and stuff like that, as they're the gold standard in the U.S. for that stuff. That would allow, I know in our industry, seats to be mounted properly, which then falls down to belts. Then they get mounted properly at the right angles, and all that stuff tends to work out a lot better.
So what you're saying is we need a centralized sanctioning body that has some rules that are a must for the dirt track racing community.
I think chassis builders could take it upon themselves, right, to do certain safety things.
Well,
because the little statement you had there about prioritizing, performance over safety is innate since the beginning of the wheel.
That's just racing.
Right? When they invented the wheel, safety went away, right? So, yeah, and I don't think a sanctioning body's going to do it, unlike NASCAR, who's, really has an iron fist, right? These other sanctioning bodies, they can do it. And the other thing is like racetracks and why they allow stuff like that is because they don't have the personnel to police it. They don't have the personnel to police it, and then they're worried about the guy. Well, Joe Blow down the street will let him through the gate, so if I don't get his $50, somebody else is going to get it.
But my thing is that, like, how, if that is true in its entirety, how does NHRA and these drag strips mandate cage inspections? What's that?
NHRA's a joke.
I get it,
Yeah.
but I'm just saying, even if I go faster than a 12.5, I have to have an inspected cage.
Yeah.
Right.
Well, the
Just
thing that you run into, like in our world, is, from a dirt late model standpoint, World of Outlaws and Lucas both have done a good job of trying to get some of these safety things put in place between the seats, between the fuel cells, between the fire bottles, and it has made great gains in that market. But you know, the sport compacts of the world, the hobby stocks of the world, the more guys that are doing more stuff in their own shop of the world, I think that's where something like this getting out to them to give them that information, because I mean, there's really never been much information out there to be available to that world. Whereas like in NASCAR, it's, you know, heavily sanctioned, it's heavily inspected. You know, you go to one of those events and they'll have 150, 200 inspectors there. So they have the personnel to do that. You're never going to have that in this world.
I get it.
So I think having the information available, like what we're trying to do here, is good. In the sprint car world, the open wheel world, the mini sprint world, there has been some big pushes there trying to make that safer and better, you know, from a performance versus safety standpoint. In the U.S., for years, there's been talks of wanting to get the halo bars in, the Stevie Smith bar mandated, things like that, to help some of the things that's happened in the U.S. Well, whereas like in Australia, those have been mandated for years.
Right.
That halo bar that goes over the top, where, you know, the wreck that took, oh shoot, I lost his name. Clausen was one of them. Raging Cajun, what was his name? Jason Johnson. He was another one. That halo bar would have more than likely saved him. But no one would run it because it was a performance disadvantage and it wasn't mandated. But I think, you know, it's all coming down the line. There's a lot of cars, you know, you go to the shootout last week with 900 entries, over half of them had that halo bar in now.
Right. At some point, people just become self-aware. And
Yeah.
like, okay, I'm just going to do this for me, regardless of what the impact, right?
Yeah, we'll figure out how to make it work.
Well, and I was impressed to see, I mean, really the sprint car community is actually doing a pretty solid job at trying to get
Yeah.
safer. I mean, because they're the more catastrophic, you know, like wrecks. And
There's still
elaborate.
still some things there that need improved. Danny Dietrich's a prime example. I get on Danny's tail every time I see him. His head is over the top of his cage.
Well, and I saw him doing, and this was several, you know, an old video, and I actually tried to reach out to the company who was doing the testing so that I could get some insight from them if it were still operation, how it was going, et cetera. But I saw them actually doing drop tests, you know, outfitting the cages with strain gauges, doing drop tests, and actually trying to correlate the stresses that a real world was, you know, how it matched up to the simulations for those particular loads.
You may know, what's the distance that your head moves in a rollover?
4
Vertical.
inches, probably.
I think that's dependent upon a lot of factors.
Yeah.
That's dependent upon seat, that's dependent upon seat belts, that's dependent upon the body.
Yeah.
It'd be tough to say.
Yeah, I mean, it moves a long ways, but yeah, Danny's head is usually even with the top of his cage, and he won't run a taller cage. He's a tall guy. He won't run a taller cage because it's such a performance disadvantage.
Yeah, that's just a choice at that point.
It
You know?
is.
I mean, it's a choice.
And
like I said,
we give him a
as-
hard time about it all the time.
Well, as racers, we make those choices. I mean, and you're the only ones that can make that choice. But all I'm saying is, you know, you can't get on the internet and bang on a keyboard and complain about a sanctioning body and still be making those type of
Yeah.
choices. You know, so I mean, you know, you can't save them all, but you know, if we can save one or two, I'm through. Brian, Ben, I want to take over.
All good?
Thank y'all.
All right.
Thanks. Appreciate it. Appreciate it very much. Y'all want to take a quick break and run the restroom and
Yeah.
phones or anything real quick?
That'd be good.